What's going on, everybody? This is JD from Engine Squared. Today, we're going to be presenting you our first parametric modeling tutorial where we'll be modeling a shed using Onshape. At the time of recording this video, we just hit 500 subscribers. We'd like to thank our audience, you, and our partners for helping us achieve this. Without further ado, let's get started. Okay, so we got started by creating a new document in Onshape called Shed Tutorial. You can name it whatever you like. Before you get started, you're going to want to make sure you have the beam feature in Onshape on the top right. So there will be a link in the description for accessing this feature and loading it into Onshape. You can check that link out for getting this feature integrated on your end. We have the origin, we have the top plane, front plane, and right side plane. Since we're going to focus on modeling just the structure, we are going to want to create separate planes that we can use for reference. And this helps when you have a different foundation for a building so that you can adjust your model accordingly and have a nice CAD file reference. So we're going to go ahead and select the top plane, and we're going to create a new plane. For now, we are just going to offset it by 12 inches. So right away, we are going to create a parameter for this called level 1 offset. And the value of this parameter is going to be 12 inches. So we're going to want to move that up so it's first in the tree. And we are going to insert that over here. See, we're calling it by the name that we named it, and then click enter. So in this case, it's going to stay in the same spot because we already put it at 12 inches. So we're going to name this plane level 1. Now, this is going to be our sketch plane for the plan. So we're going to create a new sketch on the level 1 plane. We are going to use the center point rectangle feature and click the top view. Now we made a perfectly centered rectangle. We'll dimension these now, whatever it ends up being, and we will click OK. So now we're going to create parameters for the length and width. To keep it simple and consistent with the CAD file, we are going to name the length Y and the width X. And for the length Y, we are going to make it 8 feet. And for X, we are going to make it 7 feet. So just like the first parameter, we're going to select both of these and bring them back to before we created any features in the model. And now we're going to open the sketch again by double-clicking it. Double-clicking the Y direction dimension and typing in Y to call the Y parameter that we made. Then we're going to click enter. As you can see, it updated to the 96 inches or 8 feet that we defined. We're going to do the same for the X direction. If we change these dimensions, we can see that this changes to 9 feet, that dimension adjusted. We can change this to 12 feet, that dimension adjusted. We can change the offset to 24 inches. You can see that adjusted. So we're just going to bring them back to how they were before. And we're going to right click the sketch that we just made and call it level 1 underscore plan. So now we're going to hide this temporarily. We're going to hide this sketch. And we are going to do another plane that's an elevation reference from the top plane. And we will just put a blank parameter there for now, 60 inches. And this is going to be the lower roof elevation. So we are going to call it bottom underscore roof. And we're going to make this 9 feet in height. So we're going to bring this parameter back again. Double click the new plane that we made. Call the parameter we created for bottom roof. Click enter, and you can see it adjusted to that dimension. Now we're going to rename it bottom underscore roof. So now we will select the front plane to get an elevation view. We will create a sketch on the front plane. Right click, view normal to sketch plane. And now we're going to unhide the level 1 plan. And if we rotate around, we can see that perspective in 3D. So we're going to call these points. It could be these two or those 2 points. But we're going to call these ones here. And we will click project so that we project them onto the front plane. This way, the sketch is linked to the plan sketch. And now we will create a line. And we're going to hover over that point. Actually, first, we're going to hide the plan view so that we make sure we are constraining just to these points that we projected. Going back to the normal view, we are going to hover over the point at some distance to the right of it and create a line going straight up. And this line is going to stop at some point before the bottom roof plane. We're going to hit the escape key to end the polyline. And now we are going to create some dimension references from the point to the line. And from the other point to the bottom roof plane. Opening the variable table, we will now define these offsets. We are going to call this first one perimeter wall offset. And the second one bottom roof offset, using abbreviations to make them shorter. Since we'll be using 2x4 wood studs, we are going to create the perimeter wall offset to be 3.5 inches divided by 2. Bottom roof offset for now can be 0. Now we're going to double click the first offset and enter the parameter that we created for the perimeter wall offset. We will click the second offset and enter the second parameter that we created for the offset. Now we'll follow the same steps with a slight modification for the other side of the shed. Except this time we will go higher than the bottom roof offset. We will use the same perimeter wall offset for this member, but we will create a new parameter called upper roof offset. This one will be 12 inches. Now we'll select the top point and the bottom roof offset plane and call the parameter that we created for the upper roof. Now we'll click OK to finish the sketch. We unhide the level 1 plan. Now we can see we got our basic framework started. We will rename the sketch we just created to Framing Elevation 1. We can now open the beam feature and use timber for the standard, lumber for the profile, and 2x4 for the size of the lumber. Now we can select the lines we just made, and Onshape will auto-generate the 2x4 wood pieces. We will grab all these parameters and put them to the start as we did before. Because we created them while they were in the sketch, by default they were ordered before the sketch. Next we will open the level 1 plan and create the bottom plates for the structure. This will be achieved by creating a line parallel to the perimeter line. We will mirror this line on the right plane. We will offset this line by the perimeter wall offset parameter. Notice how the other line updated accordingly. We will constrain the ends of the line to the perimeter of the structure by making the offset 0. Using the same approach, we will create bottom plate lines in the perpendicular direction. Except for the offset, we will use the perimeter wall offset from the center of the other bottom plate. Confirming the sketch, we will now open the beam feature again. The 2x4 will be preset as we previously set it. And we will select the new bottom plate lines that we created. Notice in the parts list, now we have 6 parts, the 2 verticals and the 4 bottom plates. If we shift select all 6 of these parts, right click, and check interference for these 6 parts, we will see there is a clash on both the left and the right side. We will address this later in this tutorial. Notice how the bottom plate is going to the center of the vertical. We want to correct this by going back to the second beam feature we created for the bottom plates and dragging it upwards. This will generate the profile offset from the beam centerline reference by half, as opposed to being on the center. We will accept this change. Going back to the framing elevation sketch, we will add another line going between the 2 points shown here. We will extend this line past the 2 points. As you can see, when we zoom in, they're not connected. We are going to use the coincident feature to constrain the line to both of these points. We will create dummy offsets for these extensions, using 30 inches as a value. Finishing this sketch, we will now create another beam feature, this time using a 2x6 lumber profile. Notice how it is centered on the top of the points. We want it to be referenced to one side, so we're going to drag it down. We're going to accept this change. Now there are several ways to get rid of these clashes. We are going to go with a simple method for this. First off, we will create a new sketch on the front plane. We are going to hide all the parts in the view by clicking the Hide All Parts button. We are also going to select the reference lines and points shown and use the project feature to project them onto this new sketch. We will create new lines from the new points to the sloped feature. Make sure it's vertical as shown. Notice these points are fully constrained to the slope. Using the trim feature, we will trim off the extensions, as well as the points that are isolated. Finally, we will create a new line on the bottom, then select all of these perimeter lines, and we will use the offset feature. We will change the offset value to 50 inches. We will left click to accept. Now, if we unhide all the parts and look at this new sketch in the front view, We are effectively going to create a remove extrude that eliminates everything in the orange highlighted zone. Clicking extrude and switching to remove, we will select the outer face of the new sketch, not the interface, and select merge with all, which means it will remove from every single part that comes in its path. We will select symmetric. We will change the extrude type from blind to through all. Notice how we are excluding the bottom plates here. After clicking OK, we can see that we extruded everything outside of the perimeter lines. To reset the view, we will right-click the cube on the top right and click isometric. Now to get rid of the clashes, we will click the Boolean feature, subtract. We will check the Keep Tools button. For tools, we will select the top beam. For targets, we will select the verticals. Clicking OK, we will see now that the clash is no longer there on both sides. We will repeat the step for the bottom plates. Subtract, select the bottom plates as the tools, and the verticals as the targets. Now our model is clash-free. We will rename the latest sketch we created to elevation_remove. And we will hide it. We will start by creating a linear pattern feature for the existing frame. We will select the two vertical elements and the roof beam as the entities to pattern. We will click the direction box and select the front plane as the direction for the pattern. For the distance, we will start by calling the y parameter, clicking enter, dividing this by 2, and subtracting this by 2 times the perimeter wall offset. Furthermore, we will subtract this by half the thickness of the stud, which is 1.5 inches divided by 2. Clicking the left view and turning on the translucent feature, we can see this is perfectly aligned with the inside of the bottom plate. We will now enable the centered feature in linear pattern to copy the frame on both sides. We will increase the instance count to 4. And we will enclose the previous formula in brackets and divide this entirely by 3. Now we will click OK. If we measure from face to face with the studs, we can see the spacing is 14.5 inches, which is acceptable for the purposes of this tutorial. We will turn back on the shaded with edges view. Now we will hide all the 3D parts and create a new plane reference to the front plane. We will call the Y parameter, divide it by 2, and subtract it by the perimeter wall offset. Notice how now this plane is centered with the bottom plate. We will click OK and call this new plane entrance elevation. We will copy the formula and create another plane referenced from the front plane, except we will click the button to change its direction and paste the formula from the previous plane we created. We will call this plane rear wall. Now we will create a new sketch on the entrance elevation plane. We will call the bottom plate and the 2 points of the other bottom plates, and then project them onto the sketch. We will also call the endpoints. We will create a vertical line offset from the endpoints. We will offset the top point of this line by 0 with the roof, and horizontally by 1.5 divided by 2. We will do the same for the right side. We will also project the extended top line. Finally, we will create a line in the center of the sketch, extending vertically past the top line. Top of this line will be constrained to the bottom roof plane using the upper roof offset. We will add a few inches just to be safe here. Now, using the beam feature, we will change our profile size to 2x4. We will rotate by 90 degrees and click OK. We will unhide the sketch, rename it to entrance framing. Once again, using the beam feature, we will create the verticals, selecting all 3 lines we just created in the sketch, and we will rotate these by 90 degrees. We will go back to the beam feature for the top plate and drag it downwards to be offset from the sketch line. Now we will pattern the center stud in the direction of the right side plane. For the distance, we will call the x direction dimension and divide this by 2, just as a starting point. We will further subtract this by 1.5 inches divided by 2. We will change the instance count to be 3. Now we will take the entire formula we created above and divide it by 2. We will check the centered feature to duplicate this to both sides. For the instance count, we will subtract it by 1. Now, going back to the elevation remove sketch, we will repeat the same steps that we did for the center frame. Notice how we will get rid of all the features above the roof perimeter. We will now hide the remove sketch and click the Boolean feature and subtract. We will select the top plate as the tool and the verticals as the targets. Make sure that Keep Tools is selected. If we unhide the 3D by clicking twice, we will see that this wall is in perfect alignment with the A-frame. Another clash we need to get rid of is the clash of the verticals with the bottom plate. There are multiple bottom plates here, so we need to make sure to select all 3 of these as the tools. The targets will be the verticals. Now our model is clash-free. Measuring between the studs, we can see that the distance is 20.625 inches. We should decrease this by going back into the model. Expanding our previous formula, we should divide it by 3 instead of 2. For the instance count, we can bring it back to 3. We will click OK to accept this change. Notice that everything updated correctly, except for the 2 new parts that we need to relink the booleans to. So for boolean 3, we will add the 2 new studs as the targets. And for boolean 4, we will also add the 2 new studs. Now our modification is fully linked. Measuring between the studs again, we have 13.75 inches, which for the purpose of this tutorial is acceptable. We will take the new parts created here and use the mirror feature. mirror plane will be the front plane. Notice the preview. Click OK. And now we have the base of our structure completed. Now we will create some bridging for the centers of the walls. For the lower wall, we will create a new plane offset from the right plane. We will call the x parameter and divide it by 2 as a starting point. We will subtract this by the perimeter wall offset and accept this change. This plane will be called lower wall bridging. We will create a new sketch. We will hide the 3D and we will project the bottom and top of this wall from the sketches. We will create a reference point in the center of this line. We will create a line going from left to right. That is constrained to this point. Unhiding the 3D to get a preview, we will constrain one side of this line to be the y parameter divided by 2, and we will constrain the line's length to be the y parameter dimension. We will keep whatever change we make to one parameter consistent to the other parameter. We will use the perimeter wall offset parameter multiplied by 4. And we will copy this formula to the half point formula and close this one in brackets and further divide that by 2. Now we have our bridging stopping at the end of the A-frames. Now we're going to copy the name for the plane and apply it to the sketch for consistency. And we're going to repeat this step for the higher wall. We can speed this up by copying the formulas. And copying the names, making slight modifications. The previous step could also be done by selecting the center point of the higher line, projecting it. We can project the lower wall bridging line and make it into a construction line as a reference. That way we don't have to apply the formulas twice. Now we'll unhide the 3D and create the bridging for both walls. Rotate the 2x4 stud by 90 degrees. Using the Boolean feature, we will select the vertical profiles on both sides. As the tools used in this Boolean, make sure to select the subtract feature. The targets will be the two horizontal beams. Notice how this got rid of the clash and split each beam up into a separate part. Finally, for the bridging, we will use the transform feature to stagger them. We will move one set up 2 inches and move the other set down 2 inches. To make the structure a little bit more sturdy, we're going to use the linear pattern feature to copy these upwards. We will do one side at a time, as the offsets are different. We will select top plane for the direction, and the distance will be the bottom roof elevation minus the level 1 offset. We will enclose this in brackets and divide it by 2. We will also subtract this by 2 inches. We will need to reorder the linear pattern to before the transform features, and notice how this straightens out the studs, because this copies the studs before they were transformed to stagger them. We will repeat the same step for the other side. Except for this side, we will use the top reference as bottom roof elevation plus the upper roof offset minus the level 1 offset. We will enclose this in brackets and divide by 2. We will also subtract this by 2 inches. Furthermore, we'll reorder the linear pattern to appear before the transform features. The last step of this tutorial will be creating the door opening. First, we'll rename the sketch we created for the higher wall bridging. We will create a new sketch on the entrance elevation plane. Hide the 3D, and we will project the reference lines. for the front elevation. Make these construction lines, as we don't want to use them in our model. We will rename the sketch to door framing, and we will hide all other sketches. Show the 3D to get a rough idea of where the existing studs align. Now we'll hide it. We'll start by creating a center rectangle where we would like to place the door. We will define some door parameters. 30 inches for the width and 6 feet plus 8 inches for the height. We will also constrain the bottom to be a 0 offset. Constrain one side of the door to be offset from the perimeter of the shed. This is something we will create a parameter for called door offset. Now we've linked this to the variable table. This box here we will assume as the rough opening for the door. That means the framing has to go around it. We will add 2 lines on each side, constrained to the level 1 elevation and the roof slope. We will offset the center of these lines by 1.5 divided by 2. We will offset the furthermost vertical by 1.5. We will repeat the step for the right side of the door. Finally, we'll create a header. Make sure the header line is aligned with the door opening. We will offset this by 1.5 divided by 2. Finally, we will add another vertical in the center. The top of this vertical will be constrained to the roof slope, and the bottom will be constrained to the center of the header with an offset of 1.5 inches divided by 2. Now we have our door framing sketch complete, and we will click OK. We will move our door offset parameter to the start of the model. And before we start using the beam feature, we are going to need to create another remove sketch. For this remove sketch, we will be projecting the door opening. If you can't select a line, you can right-click the area, select Other, and go down the menu until you see the line you want to project. In this case, it's the rough opening for the door, which is edge of door framing. We will project it, and we will also project the roof slope. And we will change this back to a modeling line. We will now draw two vertical lines, one on either side of the door opening. These lines need to be constrained to the roof slope and to the level 1 elevation. Make sure that when you sketch a line, it is not auto-constraining to undesired features. On the left side, we will dimension the offset as 1.5 inches times 2 as a starting point. This will cover any framing that's in the way of the king studs. We will add an additional 16 inches divided by 2, which is 8 inches, to remove any other framing in the way. We will copy this formula and bring it to the right side. But for now, we will only add 2 inches to this. Because it's closer to the perimeter of the shed, and we don't want to delete the end stud. Accept this change. And now we will unhide the 3D. But we need to make one more modification. The top line should be offset by the top plate thickness. We will constrain this line to be parallel with the roof slope, and we will add 1.5 inches for the offset. We will accept. We will rename the sketch door remove, and we will unhide the 3D. We will hide door framing for now. We will also add another line for the bottom plate. As for now, we don't want to remove this. We will offset this line by 1.5 inches. Now we'll unhide the 3D. We will now remove the framing features that we don't want by clicking Extrude, Remove, and selecting the two regions shown here. For the depth, we will use perimeter wall offset. We will copy this to a second end position, which we will enable. and we will use merge with all for the scope. As you can see, the preview shows that the vertical framing has been removed. Now we will unhide the door framing sketch and use the beam feature to frame these elements. We'll start with the verticals and rotate them at 90 degrees. We will accept. We will use another beam feature for the horizontal beam. We will also rotate this at 90 degrees. We will create a linear pattern to copy this header by 1.5 inches. For the final time, we will be going back to the elevation remove sketch. We will repeat the same process as before. Merge with all, through all, and symmetric. Notice the preview showing the trimmings of these studs disappearing. We will now hide the sketch. We will hide the door framing sketch. And we will use the Boolean feature for the last time to get rid of the clashes. The tools will be the top plate and the bottom plate, while the targets will be the verticals. We will also select the duplicated header and the center vertical as tool and target, respectively. Click OK. And now our framing concept for our shed is complete, and it should be adjustable to when we modify the parameters. Let's give it a test. So first of all, when you generate members with the beam feature, you can open the custom tables in Onshape, and you should see a cut list. This cut list will show every part with all the quantities at each of their associated lengths. You can just highlight over each item in the table and it'll show you which part is being referred to. This is particularly useful for projects like this, where you have a lot of different cut lengths. So let's test this out. Keep in mind, parametric modeling is restricted to certain extents of parameters. For the purpose of this tutorial, this concept only works within a very limited range of parameters. If your parameters are too large, there will need to be a modification to the parameters to make it suitable. Switching to the perspective view, let's give this a shot. Start by modifying the level 1 offset. Let's make this 24 inches. Notice how the entire model adjusted. If you go to the custom tables, all of these lengths have adjusted as well. Let's change the Y dimension. Right now we're at 8 feet. Let's do 7 feet. As you can see, the model has shrunk, and now the parameters are also updated. For the width, let's change it to 8 feet. As you can see, the model has adjusted to the 8-foot width or the 8 feet dimension in the X direction. Notice how this stud spacing is a little bit too high. This can be fixed either by manually inserting a new stud or adjusting the formulas to suit. We can leave that for another tutorial. For now, we are going to change the X dimension to 6 feet. Notice how the model has updated. The cut list, again, has also updated. Now for the most exciting and potentially problematic parameter. We are going to modify the upper roof offset and see if this works. Currently, we have 12 inches for the upper roof offset. We are going to change this to 24 inches. As you can see, this parameter has successfully worked, and the cut list has been modified accordingly as well. We're going to pan around this model using the space mouse. Directly from Onshape, you can take the cut list, click Copy Table, and insert them into a spreadsheet. We can attribute each list to a picture of the shed. We can use Ctrl-Z to go back to each previous design iteration. Using Ctrl-Z, we have copied the tables for each iteration of the model previously shown and inserted them into a spreadsheet software. This can be used to create a product catalog after careful calculations and model verification. We are going to use the original design parameters to finish this model and make a render. We will select all the lumber profiles, assign a material, and use cedar western red. This will give each wood profile the material properties of cedar wood. We will once again select them all and edit appearance. We will select a color that resembles wood. Now we're going to insert this into an assembly. By clicking Insert and selecting the Part Studio. When doing this, be sure not to click in the white space to move the model, as this will change the origin in the assembly file. Now we will insert a new tab and create Render Studio. In this Render Studio, we are going to create a new version in the Shed tutorial document. to reflect the changes we previously made. And we're going to select the assembly that we inserted the parts into. As you can see, because we selected the cedar western red material, Onshape has preloaded this graphic. We will select all the studs, and we will find a wood texture that we like. We will use this oak wood texture. We will right click it and assign. This looks a lot better, but there's one issue. The grains are not aligned with every part. Leftwards selecting the vertical profiles, and left select that as well. Now we will go to the Appearance tab on the right side. We will rotate this by 90 degrees. If we unselect, we can see that the grains are now oriented in the correct direction. You can apply the appearances separately to change the grain orientations for different members. As you can see, we would need to change them for the horizontal members and the sloped members. But if you got to this stage, I think you get the idea. For the render, we are going to turn off the shadow. And turn down the lighting intensity. We can render this scene by clicking the Render Scene button, orienting it to the view that we would like. I like to remove the background so that it's a transparent PNG, and then click Download Image. This will render it and save it to your disk at the same time. We hope you enjoyed this tutorial. Stay tuned for future parametric modeling tutorials with Ngen Squared. Thanks for watching.